Hi, I'm Alan Ross. I am the curator of the Transformer Technology community and the editor of Transformer Technology magazine. My guest today on this Tech Talk is a gentleman that I just delight in talking to, Luiz Cheim, who is the inventor of the Explorer from what was ABB and is now Hitachi ABB. Luiz, thank you for joining us.
Sure, my pleasure.
We talked before. I saw the Explorer work in a tank that Craig Stegemeier, a former ABB engineer, had, and it was going up and down, and he was actually using it remotely controlled. I think it was at a Doble conference, and it was so impressive to me that I hung around for a long time. Craig mentioned a lot more of it. Your name came up as the innovator, the inventor, and I was fortunate enough to track you down. And we'd like to talk about the Explorer and how it came about. When we talked before, you had mentioned collaboration and how it took a lot of collaboration. I want you to comment on that, from innovation to collaboration to outcome. Talk a little bit about the collaborative part of this within ABB.
Yeah, okay. Thank you. Well, as I mentioned before, I mean, I had the idea, the initiator of the product, if you like, as a concept. But in those days, I was working in the transformer service organization. Today, I'm more on the R&D part of the business.
Right.
Totally dedicated to R&D, and there I was doing R&D as well, but supporting the business directly. So I had some other functions. And of course, as a transformer guy and surrounded by transformer guys, we had no idea on how to move forward with that idea of a device to be inserted into an expensive asset like a transformer. And some people didn't believe that it would even be accepted by the users around the world to insert some foreign body, alien stuff into their transformers. Yeah, so there was some important reaction in those days. But nonetheless, the idea gained support internally, and we started discussions with another division, completely different business from ABB, called the Robotics division, that, by the way, stayed with ABB as we separated. Now we are in the power grid businesses, and they are still with ABB, the Robotics. And they were excited about the idea as well. And it was a matter of discussing the principles, how to work together, where the funds would come from, maybe partially from each side, how we could make this work as a team that had never worked together before. And that is how it came about. So the company believed as a whole in the idea, put a few $1 million and some 4 years for the development of the first meaningful prototype that we could show around, for example, in fairs and things like that, exhibitions. And it's been a success since then. But again, without this cooperation between these two different groups, transformer guys, service guys, and the robotics team, this would never be possible, in my opinion.
So during the 4 years, I doubt very seriously if when you started that, you said 4 years from now we'll have it. Did you ever hit a bump where you thought, will they stop believing in this, that we're not going to do it, that you had to overcome? Or did you plan all along that it would take 4 years?
Yeah, very, very good point. In the beginning, we were distracted by the idea of the robot itself, and we forgot a few constraints of the transformer. And the first actual prototype that we started testing inside our factory in St. Louis was a ball-shaped robot. Real ball, spheric thing. But that ball-shaped robot was too big. We forgot a small detail, that space is of paramount importance inside transformers, particularly if they are not too big a transformer or or if you have other manufacturers that perhaps may select designs that are tighter and smaller for the same ratings and so forth. So we had to rethink, and that was a big bump, because and then there was the risk that we would not be able to redesign the whole thing and minimize it or miniaturize it, if you like, or as much as possible, because there was a lot of electronics behind it. There are lots of communication things, navigation, controls for the remote operation, and there's so many details, the lighting. So there were so many technical details to move from one design to another completely different, that there was a big risk. That was a time during the development that we were a little bit, let's say, scared that this thing would not be successful or totally successful. But we took the challenge on, and we faced all the hurdles, and I think we were very successful there as a team again.
Yeah. That's an important aspect. That's one of the things I wanted to make sure we brought out. While you may have been the brainchild of, hey, if we could do this, it took major commitment from ABB, what is Hitachi.
Oh, sure.
Do that. So you just mentioned three things that I want to touch on. Communications, the difficulty that you have with that, the camera / lighting, making sure that you could see in there, especially an older oil-filled, dirty oil transformer. And then all of the parts, navigation parts and fins and everything that you had to do. Just let's start with the communications. What did you have to overcome from a communication standpoint?
Well, the first big hurdle was the Faraday cage, because if you don't remove the oil and you don't actually open the transformer, you just have an entry, let's say, point for the robot. You end up with a Faraday cage full of oil. So for the radio waves or the communication waves to come out of that environment was a challenge as well. So we end up, particularly the guys on the robotics team. I was at that point I was more like an observer and supporter of the thing, and cheering them up and rooting for all the attempts to solve all these technicalities than anything else. But they were, I mean, my colleagues there, they were great in looking for alternatives, like having antennas that is halfly submersed near the entry point of the robot, that would then operate as an intermediary with the outside, have the necessary, let's say, hardware in the robot that could, with power or enough power, send these signals, image, pictures, to the outside through this communication, let's say, bridge. But again, in the beginning, we also had the quality of the images were not so good. Maybe some delays in transmitting the images, blurs. The pictures were not of so good quality. So they had to search and look for better ways of doing the same function, but maybe with better equipment, more sophisticated hardware. And also the processing, the signal processing. There was a lot of, let's say, investment into the signal processing, let's say, capabilities as well on the outside. Once you get those signals, how can you process them so that you have, let's say, very fast conversion of the image and a good quality image, so that you can almost immediately see what the robot is seeing with quality there. Regarding the environment, I remember we started from water, almost water-like dives in the robotics laboratory, moving on to tea and very dark tea, yes, emulate the dark oil before we actually took it to actual real dives in old transformers at our factory in St. Louis. So this was like a step-by-step process, improving here, improving there, coming back and test. And so there was a lot of back and forth And then there was the material as well. You asked about losing parts and so forth. That was particularly from my side, because I've been around and helping utilities solving problems regarding the condition of their transformers. And I know that sometimes, for example, people in the maintenance world, as you know better than I do, may leave like a tool inside the transformer or something, and the transformer will be destroyed. There is a failure, and when you investigate, there was a screwdriver there or something.
Or a wrench.
So, yeah, range. So or losing parts would be totally, it could kill the project if we had the minimum risk of this device just losing parts inside the transformer. So we, since the beginning, since day one, we put that as a top-notch requirement. This thing has to be self-contained. If something goes loose, it has to fall inside itself. It has to contain itself. So now we are confident that the risk of the robot losing or leaving behind anything is almost inexistent. I don't think we can say statistically zero, but we did the best the human mind can do to make sure that this thing would never happen.
From a reliability standpoint,
the
only way to get to 5 nines, which is 99.999% reliability, is to have some redundancy, which would be 2 robots. So you could not do that. But so when you think about all of the different things that you had to overcome as a team, and then again, you had to get corporate commitment, leadership to say, hey, we're going to stay with this program. I think it speaks volumes to the culture that you and the robotics team and the rest of the service team were allowed to continue to solve the problems. You have just defined, and I know you know this because we're going to talk a little bit about your R&D focus. In R&D, you start with something, and then you find out things that you didn't know when you started. And there's too many people that say, oh, no, we're going to give you $1 million in 2 years. And guess what happens? Sometimes you invent something else. You say, oh, in this research, we came up with this. But that's a huge commitment to the culture that allowed that to happen. And a huge commitment from your part to provide some leadership of something that you saw and you had to walk through all of these things to get to. I want to talk about the actual working of the robot once you drop that in. I know there was an example that in Australia, I think it was, where, and I think it's fascinating. I wanted you to say, oh, here's an area where we went down and we found a broken transformer and we told them to fix it. You actually told me about one where they went down and said, nothing's wrong with the transformer, energize it. That's amazing, because think about the amount of money, time, and energy they say.
Yes, yeah.
Talk about that example.
Well, Alan, but I think that is more frequent than not. That people are suspicious. And as you know, then there is a decision to do inspection. You go there and you invest a huge amount of money to the logistics. You need to disconnect the transformer. Sometimes ask some external operator to give you permission to disconnect your transformer. This is very common in certain countries. And then so it's your transformer, but someone else operates it. So it's a huge issue. So all the intricacies, difficulties, and costs, and then you have to send the crew to physically disconnect the transformer, open the inspection window. Oh, sorry. Instead of the robot, you have to do all the other stuff, right? Drain the oil and then open and then send someone inside. So it's a huge, let's say, undertaking.
But I want to go back to that, because when we first started talking months ago, you mentioned about an affiliate, someone that you worked with at a site
doing this that I just mentioned,
the transformer, and it was hot, and he would have to come out and take oxygen. That's the solution. What is the problem you're solving? It's dangerous, it's expensive, it's time consuming. The solution is take the danger away, do it in a cost-effective way, and do it quickly. So I love the problem and the solution. But I
Yes,
think what we're talking
exactly. So to me, the beauty of this robot, Alan, is exactly this. It's not the robot itself, but it's the problem that it solves.
yeah,
I mean, it minimizes the human, let's say, risk, the very unfriendly environment that you are forced to be in when you do this inspection. There is no way out if you want to do that by a human expert. As it is done, has been done for, I don't know, a century. And then the costs, all this, logistics for disconnecting the transformer, draining the oil. By the way, after you do the inspection, oh, I remember exactly now the point that I want to mention. So more frequently, I would say than not, when you do all this, when you put the transformer back, you do that because you didn't find anything, or the inspection, the human inspector said, well, I just found this little spot here, but I can't see anything else. So everybody decides to take the risk and put the transformer back into operation. This is, I would say, is more frequent than not. So coming back to the R&D thing that you mentioned before, Aaron, let me just touch this thing here. What I really like that moves me actually, it's to me is an inspiration from this company, is the fact that there was no project on this. So one thing is development. One thing is development, like the robot itself. Okay, now we have the robot. By the way, we have 3 or 4 ideas for the future of this robot as well, in terms of improvement.
Yeah.
So this is development. Now, pure R&D, when you start from an innovative idea like zero, there isn't anything out there, and the company bets on it and say, well, let's do this. I mean, from zero, there wasn't anything at all. So this is fantastic. I take my hat off to ABB in this case, particularly, in special, because I think it's fantastic.
That brings me to a question. We are gonna continue to talk throughout what you do, because every time you come up with something, you're doing some R&D without having to have the CIA come and shut me down. If you tell me, what are you working on now that is exciting? What is it that gets you up in the morning to say, I really like what I do?
Yeah. So since the times of the robots, I was already working on a different, let's say, area or field, if you like, which is developing algorithms and helping our company to implement, let's say, software and asset management solutions that could be used by our customers online and without the direct interference of ABB. So I was working on algorithms that would emulate expert knowledge and bring that to software, to asset management, automated applications to look, let's say, over a large fleet of transformers. By the way, we've been doing that now since 2014, 15 to several customers, not only in the US, around the world. Very large one here in the US that is, can only tell you that it's present in 13 states in the US, the transmission company. So, but there are others, large ones in the US as well, Mexico, and many other countries around the world. Now, those algorithms started as expert rules-based algorithms. So algorithms based on the knowledge that we have in our books, in our expertise, in our experience, available in the industry as well, IEEE, CIGRE, and so forth.
Yeah.
And we converted that, and that was my main role. We converted that into software application that can work for the benefit of the asset manager looking over a fleet of transformers. Now, because of that, I started working and learning in a very hard way new algorithms related to AI, artificial intelligence, and machine learning.
Yeah.
And interesting enough, in 2018, then I had this, I present this paper in Paris, CIGRE Paris, And the title, because I learned all these tools, all these techniques, and I asked myself, let me try this thing with data from transformers, real transformers. Let's see if this thing can, for example, if these algorithms can identify the condition of these transformers as human experts would do, or as close as possible. And so I did that. I said, well, interesting results. And I proposed a paper to CIGRE. They accept the paper. And then I got this prize. It was the best paper of 2018. I got the best paper award. In my opinion, the main reason for that was not the beauty of the paper, was the novelty again.
Yeah.
Because the title of the paper was Machine Learning in Support of Transformer Diagnostics. So if you search the CIGRE database or even the IEEE database, you have a hard time to find papers that do that in a comprehensive way before the year 2018. So I think it was more the novelty. Now lots of people are working on this, and I have been working even harder in this field. So you were asking for about my activities. So what I'm doing right now is concentrating my time and energy. Well, the company is interested that I continue to do that, in develop better algorithms, or maybe faster, more sophisticated algorithms to help our customers to fundamentally avoid transformer failure, and algorithms that can even learn from data, algorithms that can learn and train themselves with data coming from the sites. This is what I am doing right now. So using learning to implement and to develop new algorithms and new techniques with more sophisticated algorithms and techniques. Yeah.
So I am going to propose another. We're going to have to close this one up. I'm going to propose another one of these, and I would like to talk about, because I actually referred to one of your papers, to your paper, I guess it was, in an article that I wrote for the reliability industry on transformer reliability, and I think the title of it was MLAI. Farce or future, because there's so much written about it that is not useful, right? And your paper was one of those that talked about the reality it could be useful. So we will get back and talk about that. This has been a tech talk from Transformer Technology with our friend Luiz Cheim, who is doing this for a lot of reasons, but thank you for joining us on this Tech Talk today, Luiz, and we will talk again about that fascinating. You just gave us a thing to talk about next, okay? But thank you so much, Luiz, for joining us.
Thank you. My pleasure.